Hi guys, this is the video for chapter 6, lesson 1. So, in our previous chapter, we took a look specifically at triangles. This chapter, we're going to take a look at shapes that have more than 3 sides, so 3 sides or more, which we just can title them as polygons. And so a polygon really covers any shape that has 3 or more sides. Okay, so a triangle is a polygon, a square is a polygon, a hexagon is a polygon, right? A polygon is just any shape. Okay, so we're going to take a look at basically deciding how many degrees each polygon is going to have. And so if you remember previously, we talked about triangles. So we've got a triangle here, and we've talked about how many degrees all triangles will have. So if I draw a triangle here and a triangle here, how many degrees would the total amounts be for all these angles if I added them all up? If I added all these angles, angle 1, angle 2, angle 3, if I added them all up, how many degrees would I have? If you said 180 degrees, you were correct. So this triangle, the sum of all the interior angles is 180 degrees. How about this one? If you said 180 degrees, you're also correct. So the sum of all triangles, of all the interior angles of all triangles, are always going to be 180 degrees. And that's now a fact that we know. And we remember we even saw a triangle cut out, and we cut off the angles, pieced them all together, and it always made 180 degrees. It made a straight line. So let's talk about other shapes, okay? So let's talk about if I have a square or a pentagon or a hexagon or, oh, this is going to be not the greatest drawing. 1, 2, 3, 4, 5, 6, 7, 8. Octagon right there. So if I wanted to find how many degrees all these angles added up to be, how would I do that? So looking at a square, what we know is every angle has to be 90 degrees. So we could do 90 times 4 and find that, and that would be 360, right? That one's nice. But what if we have like a pentagon or a hexagon or an octagon? That's not so simple. We can't, there's no right angles that we can just multiply by however many degrees there are, right? And all these angles, they might even be different. So what's kind of cool is we can use what we know about triangles and cut out little triangles in our shape. So if I create just a bunch of triangles that make up the shapes that I drew, then if I know that each triangle is 180 degrees, ooh, that's kind of weird. So if I know each triangle is 180 degrees, then this here all adds up to be 180. This here adds up to be 180. Well, I have 180 plus 180. Isn't that 360? That would be, right? I've got an 180 here, 180 here, 180 here. So I could do 180 times 3, and that would be the amount of degrees for this pentagon. So 540 degrees. Okay, I've got 1, 2, 3, 4 triangles. So it's going to be 180 times 4. Right here, I've got 1, 2, 3, 4, 5. So that's going to be 180 times 5. Now that's really cool. Now, what if I tell you I have a decagon shape with 10 sides, and I want you to find out how many degrees that a decagon has, all in the interior angles? Well, it's going to be a pain to draw a shape with 10 sides. I already had a hard time drawing a shape with 8 sides, right? So for you to draw a shape with 10 sides, that's gonna start to get complicated. Or if I said, find out how many degrees are the sum of the interior angles of a 20gon, a shape with 20 sides. Now that's even more impossible, right? So let's see if we can find a pattern amongst the sides of my shape and the triangles that I have, okay? So here I've got 4 sides and 2 triangles. Here I've got 5 sides and 3 triangles. Here I've got 6 sides and 4 triangles. Here I've got 8 sides and 5 triangles. What do you notice? Sorry, is it? Oh, I drew this wrong here. There should actually be 6 triangles because there's another triangle. See, terrible drawing makes it hard for me to count my triangles. So there's 6 right here. So there's 6 triangles, and this would be times 6, okay? What do you notice about the sides and the amount of triangles that are created from each shape? Well, what I see is there's difference between 4 and 2 is 2. Difference between 5 and 3 is 2. 6 and 4, difference between those two is 2. Difference between 8 and 6 is 2. So basically what I find out is my number of sides minus 2 is my number of triangles that are in the shape, that are cut out inside the shape. So let me clear up some space here. So we're going to use this idea to come up with how to find the amount of degrees in the interior angles of any shape. So if I call my sides of a polygon, give it a variable, and our book uses the variable n, okay? Then let's say we go back to our pentagon here. However many sides I have, it's going to be n minus 2. That is the amount of triangles that are in my pentagon times 180. And that would be the interior angles, the sum of the interior angles. So maybe I'll be more specific. Sum of all interior angles of that shape, right? So in this case, if I know that there are 5 sides, then I would write it as 5 minus 2 times 180. That would be 180 times 3. And I think that would be 540, right? That equals 540 degrees. Okay, so now I actually have come up with an equation, a formula, that helps me find the sum of all the interior angles of any polygon. So if now I told you, find the sum of all the interior angles of a decagon, meaning 10 sides, then you could use this equation and plug in 10 in place for n. 10 minus 2, that's your total amount of triangles in that shape. So there's 8 triangles. Each triangle is 180 degrees. So it'd be 8 times 180. And when we work that out, we have 1,440 degrees. That's each, all of them added together. Now, if I wanted to find out what one angle would be, if they were all the same, if this was a regular polygon, meaning all the angles are the same, I could do that, divide by 10. So I could do 1,440 divided by 10 to find out one angle. And when I work that out, that's 144 degrees. That's one angle. So anyway, we'll get to that in a second. So let's focus on just finding the amount of degrees each angle has, or each polygon has inside the shape by practicing this formula. So we're going to basically we have this polygon interior angle sum theorem. We've even given it a name, but basically what this is saying is that the sum of the interior angles measure of an inside convex polygon is n minus 2 times 180. So basically it's saying to find out the sum of all the interior angles of a polygon, a regular like looking shape that's not crazy, is n minus 2 times 180. So we can practice this here. So if we are to write out our equations for all this, we don't have to write n anymore because now we know actually we've been given the side. So a decagon means 10. So that would be 10 minus 2 times 180, and we just did that. That's 1,440. That's the sum, okay? A 16gon, so that's going to be 16 minus 2 times 180. And so that's 14 times 180. And that's going to be what, 2,520 degrees. 30gon, 30 sides, right? So that's going to be 30 minus 2 to find how many triangles basically are inside that 30gon. And then multiply that by 180. So 28 times 180 is 5,040. Okay, so I think you get the idea. I'd like you to do these next 4 problems. Remember, this is part of your homework, so you need to do them. Show your work, write the equation out, and write your answers down. Okay. Now, you can pause and do that, and then when you're done, you can play again. So now, when we're talking about finding the measure of an interior angle, so let's say this time I'm not telling you how many sides the polygon has, but I'm giving you the measurement of one of those angles, okay? So let's say that this is a regular polygon. It's a regular polygon. So the regular polygon here, I don't know how many sides that this polygon has. I just know that all the angles are going to be the same. And one angle is 150 degrees. So this is number 1 on your study guide here. Well, I don't know how many sides. The question is, how many sides does this polygon have? So let's use the formula that we talked about just a little earlier, okay? So we talked about how if we don't know how many sides there are, it's n minus 2, however many sides there are, n minus 2, times 180. Okay? Now, if you have a shape where one angle is 150 degrees, if you, let's say, I don't know how many, I really don't know how many sides this shape has, but let's say that one of these is 150, and this is a regular polygon, meaning all the angles are the same. So kind of covering this up and not even thinking about this right now, just looking at our regular polygon. If I asked you to find the sum of all the interior angles, what would you do? If this shape had 7 sides, let's say, okay? So this shape has 7 sides, and I'm told that each angle is 150 degrees. Well, wouldn't you just do 150 times 7? Yeah, you could just do that, right? Because you already know what one angle would be. And if they're all the same, you can just multiply that by the amount. Now, in this case, we actually don't know. The reality is we don't know how many sides this shape has. So whatever this sum is, we know it's just going to be 150 times n, the amount of sides that there are, that we don't know. So we're just using a variable to put in place the number of sides that we haven't figured out yet. Now that I have an equation, Now that I have an equation where I just have the same variable on both sides, and numbers I can work out, let me simplify this. So if I um, bring my 180 into my parentheses, I have 180 times n minus 180 times 2, which is 360. And that equals 150 n. So let's subtract 180 on both sides and combine my like terms. And then I'm left with negative 360 equals negative 30n. So then if I divide by negative 30 on both sides, n's by itself here. And then 360 divided by 30 is 12. So what I just found out is the amount of sides that this polygon has. So if I have a polygon that has 12 sides and it's a regular polygon, each angle is going to be 150 degrees. So we've actually just come up with a new equation. And you don't have to memorize this, but you're going to start to see a pattern every time you start with this equation on the top. Every time you start with this one right here, it will become 180 times n minus 360. So let's try one more. So the answer for number 1 there on the study guide was 12. So let's try number 8, which is saying that each angle for a regular polygon is 160 degrees. So let's just backtrack to our information. We don't know how many sides that this shape has, so it's going to be n minus 2 times 180. Put 180 over here this time, equals 160 times n. I don't know how many sides that this shape has. So when I distribute my 180, I'm going to end up with 180 n minus 360 equals 160 n. So now I can work this out. Subtract 180 on n on both sides. And now I have negative 360 equals negative 20n. Divide by negative 20. And that is going to be 18. So this shape, if the shape has 160 degrees for each angle, then there will be 18 sides if all the angles are the same. Okay, I'm going to do one more, and then I'm going to let you guys do a few as your homework. Okay, maybe I'll do it on the study guide here. Maybe we'll do 2 more. So let's just do one more, 170. So in this case, we've got n minus 2 times 180 equals 175 times n. So if you start to like do this a few times, you're going to realize that you can actually just write this as 180. Why is this not writing? Okay. You're going to realize that you can always just do 180n minus 360 equals 175n. And so then you're going to bring your 180s together, or sorry, your like terms together. And so really you could even look at this as 360 equals 180n minus whatever n your degrees are, angle degrees times n. I don't know. So if this right here is confusing for you, just always start with this one. But you're going to start to see a pattern that every time you start with this equation, you're going to end up with 360 equals 180n minus the amount of degrees um, of one angle times n, right? So right here, I have negative 360 equals negative 5n, divide by negative 5 on both sides. So I think this one's going to be a lot of sides here. 72 sides, crazy. So this shape has 72 sides. All right, so I'll let you keep going here. Do 10, 11, and 12. Basically, you're going to use this equation up here if you want to. Let's put it up here. N minus 2 times 180 equals 1 angle measure times n. Okay, so this angle measure is 165. That would go right here. All right, so you can keep going. 10, 11, and 12. You can pause and work those out. Let's take a look at 13 now. So now with 13, we've got a polygon with 5 sides. And so we want to find out what x is. Now, first of all these angles are different measurements, but I know that x is going to be the same. So I know that the sum of all these angles have to be n minus 2 times 180, which we found earlier what a pentagon, how many degrees a pentagon has, and that's 540, I think, 540 degrees. But let's just double check. 5 minus 2 times 180, because this is a pentagon. And so 180 times 3 is, yes, it is 540. So that means this whole pentagon here is all of them added together, the sum of all these angles is going to be 540 degrees. So if I wanted to find x, couldn't I just say that angle A plus angle B plus angle C plus angle D plus angle E, all of them added to each other equals 540? I sure can. So I'm going to do that. I'm going to replace the angle with the actual expression that's used here. 4x plus 10, that's angle A, plus 6x plus 10, plus 5x minus 5, plus 4x plus 5, plus 7x. All of that added to each other equals 540. Now let's combine our like terms. I'm going to highlight my x values, okay? And then I'm going to combine those together. So I've got 4x plus 6x, that's 10x. 10x plus 5x is 15x. 15x plus 4x is 19x. 19x plus 7x is 26x. So that's 26x plus 10. And then I'm going to add that to my numbers, right? My constants. So 10 plus 10 is 20. 20 minus 5 is 15. 15 plus 5 is 20. I'm going to add that to 20 equals 540. Subtract 20 on both sides. Now I have 520. 520 divide by 26. That equals 20. So x equals 20. Now x isn't the amount of degrees that the angle is. It just means that x is 20. So if I wanted to find each angle, which thankfully this doesn't ask me to find, I could do 4 times 20 plus 5, which would be 85, right? So this would be 85 degrees. So you could use that to find all the angles. All right, now to the next part. Now we're going to take a look at the exterior angles of a polygon. So really what that means is the outside angle of a polygon. And so when we remember we talked about the exterior angle of a triangle, that's when you extend, you find the supplementary of what's on the outside of one of your angles. So like the exterior angle of this triangle here would be here. Actually, it would be this way, because I'm going to go the same direction, and then this way. So these exterior angles are all supplementary to the interior angle here. And so I want to show you this little video that basically talks about how what we see. There's a pattern that we see about the exterior angles of a polygon, no matter how many sides that this shape has. So we're going to look at, just pick out a polygon here, and basically they're showing you a picture of the polygon and how you're extending it to the sides to find the exterior angle, and then what you notice about that. So we're extending the sides and they're all going the same direction. Now they're highlighting all the exterior angles. So those little red pieces are the degrees of the exterior angles. Now we've got a circle here. How many degrees is a circle? It's 360 degrees, right? All circles are 360 degrees. So we're putting these degrees into this little circle, and we realize that the sum of all of the exterior angles of any polygon equals what a circle is, which, when we put all those angles together, it equals 360 degrees. And so every time, no matter what shape you see, if you extend the exterior angles, we realize that it's always the sum of all the exterior angles are always going to be 360 degrees. So let's take a look at our study guide again. Now, basically, if all the angles were the same measurement, the exterior angles, if this was a regular polygon, let's say, like all these inside angles are the same, these are all the same, then we know that the outside angle has to be the same. All the exterior angles would have to be congruent. They would have to be the same. So that means if I wanted to find one exterior angle, I could just do 360 divide by the amount of exterior angles there are, which are actually the same number as however many sides a shape has is however many angles that shape has. And if that shape has 6 interior angles, it's going to have 6 exterior angles. So we could just do 360 divided by 6, and that's 60 degrees. And so each exterior angle of a regular hexagon here, this is a side with 6 shapes, is 60 degrees. So let's take a look at these 3 problems here. Find the sum of the measures of the exterior angles of each convex polygon. So a convex polygon is just where the shape doesn't have any indentions like this. This would be like a concave because it caves in. So this would not be a convex, but a convex polygon. So the sum of all the exterior angles of a convex polygon. Well, don't we know that it doesn't matter what kind of polygon, all the exterior angles always add up to be 360. So a decagon is going to have a sum of 360. A 16gon is going to have a sum of 360. A 36gon is going to have a sum of 360. So I don't even have to do any math because I just know that this is a rule. This is something that's true about all exterior angles. It always adds up to be 360. So now let's find the measure of each exterior angle for each regular polygon. So now we're saying, okay, let's find one exterior angle if this is a 12gon. Okay, so we would just do 360 divided by 12 to find one of my exterior angles. For a hexagon, we would just do 360 divide by 6 to find one exterior angle. Do you get the idea? 360 here divide by 20. So you would just do that to find each exterior angle. Instead of all of them, now you're just looking for one. So 360 divided by 12 is 30. So one exterior angle is 30 degrees. This is 60 degrees. Do we just do that one? Okay, and then next one, 20gon, would be 18 degrees. So go ahead and find the rest of these. Heptagon, this means 11. Dodecagon, that means 12. So becoming familiar with these words might be important to you so that you know what kind of shape we're talking about. If you're not sure, then Google it, okay? So do the rest of those problems, and that's all I have for you.